All right, guys, today we're going to learn about solving compound inequalities. A compound inequality consists of two inequalities connected by the word and or the word or. And each of those types have very distinct looks to them, but they're very similar. Now, let's look at example 1. It says solve -5, which is less than or equal to 2x plus 3, which is also less than or equal to 7. Then we're going to graph the solution on a number line. Now you notice this x is going to, and this 2x plus 3 is both greater than the -5, but also less than the 7. So this is what we consider an and statement. Okay, when it's connected like this, all right, it's considered an and statement. It doesn't have the word and there, but you should recognize that as an and statement. Now, we're going to solve this like we would in inequality. We ultimately want to isolate that variable. So we'd start by subtracting 3. But in this case, we got to subtract both on this left-hand side of the inequality and also on the right-hand side of that inequality. So when we subtract 3 here, we're going to get -8, which is less than or equal to, this is going to be 2x, which is less than 4. Now we got to finish isolating that x, so we're going to divide by 2 and do it on both sides. And we're going to have -4 less than or equal to x, which is also less than 2. Okay, so there's our solution to our inequality. -4 is less than or equal to x, which is less than 2. Now when we go and graph this on a number line, okay, we could have, we'll go -4, -3, -2, -1, and keep going right up until we cover all the way up to 2. And we're going to apply the same open and closed circles. So -4 is less than or equal to x, so that's going to be a closed circle on -4. And x is less than 2, so that would be an open circle because it's just less than. And you notice x falls in between, so all these numbers in between -4 and 2 will work. So we're going to shade in between those two circles. And that shows all the numbers that would work right back up in that original inequality. Like we could try, like even plug in 0. 2 times 0 here would be 0. 0 plus 3 would be 3. 3 is greater than that -5, but also less than the 7. So any one of these numbers that are shaded will work in that inequality. So let's look at example 2. It says solve 6x minus 5 is less than 7, or 8x plus 1 is greater than 25. So we want to solve for any x values that will work in either one of these. Excuse me. So it's very obvious, I think, to see that this is an or statement. And what you're going to do is you're going to solve each of those inequalities and then make sure at the end that you connect them with an or statement. So we're still going to isolate our variable. So like here, I'm going to add 5 to both sides. And we get 6x is less than 12. Divide by 6, and I get x is less than 2. Then I'm going to also solve this other inequality. We're going to subtract 1 to start isolating our variable. I get 8x is greater than 24. Divide by 8, and I get x is greater than 3. Now, since this is an or statement, we really need to bring that or down in our answer. And then that's going to be your compound inequality to show that it's a compound inequality. If you don't have that or, I'm going to take points off. And then when we graph that on the number line, you're going to see it has a different look than the and statement that we did in the one before. Okay. We have 1, 2, 3, 4. Okay. Now, x is less than 2. We'd have an open circle on 2, and we'd have an arrow going to the left. X is greater than 3, we'd have an open circle on 3, and we'd have an arrow to the right. Now you notice this is different than the and statement. Okay? The and statement, you notice we had shading in between. Okay? In an or statement, the arrows are going in opposite directions, and that's the pattern that you're going to see with those. All right, let's move this up and look at the next example. And we're going to have to delete these words and get them out of our way. Do that real quick. All right, so in example 3, We have, it says solve -3 is less than -1 minus 2x, which is less than or equal to 5. And then we're going to graph the solution on the number line. Now we're back to, this is actually an and statement, but we're still going to solve. We're going to isolate that variable. So I'm going to start by adding 1. We're going to add it to either side here. And we would have -2 is less than -2x, because that was minus 2x, and which is less than or equal to 6. Then we're going to divide by -2. Now, since we're dividing by a negative, that rule still applies, that we're going to switch or reverse the direction of the inequality. So we're going to have 1 is greater than x, which is greater than or equal to, this would be a -3. Okay. Now, you notice here, what I notice here is, now that would be perfectly acceptable as an answer, but I notice that my lower number, -3, is on the right, when really it should be on the left if we're looking at a number line. So I'm going to switch the order to make it more number line order. -3 is my solid number, so I'm going to put that here, and like 1 in this case is a larger number. Okay, and now this, you can switch around the answer to get number line order. I will also still accept that answer. But for me, I like to often switch it back around, so it makes it easier for me when I go to graph it on a number line. Because obviously on a number line, -3 is furthest to the left, and then your 1 is going to be furthest to the right. Okay, and again, our open and closed circle still apply, so it's -3 is less than or equal to x, so it's going to be a closed circle on -3. And x is less than 1, so that's going to be an open circle. And the x is going to fall in between there, so we're shading in between. Okay, let's look at the next example. It says solve and graph, then check graphically whether the x value is a solution. So you notice we have to solve an or statement here. We have -2x is greater than or equal to 6, or 2x plus 1 is greater than 5. Then we have x is equal to 0. So we want to solve this in or compound inequality first. Then we're going to check to see whether 0 is actually a solution for that. So we still want to isolate our variables. So we're going to go divide by -2 on both sides. Now, since we're dividing by -2, we got to switch the direction of the inequality. So we're going to have x is less than -3, or less than or equal to, -3. And then we'll subtract 1 to solve this other inequality for starters. And we do 2x is greater than 4. Divide by 2. And I get x is greater than 2. And I want to kind of get this all in one line because I really need my or in between. So let's bring this x is less than or equal to -3, or x is greater than 2. All right, and then I graph this on a number line. Okay, let's see, start down below -3, and we got to go all the way up to cover 2. All right, so we would have, for x is less than or equal to -3, we'd have a closed circle on -3. And x is less than that, so that would be an arrow to the left. And then we have x is greater than 2. So we would have an open circle on 2, and x is greater than that, so we'd have an arrow to the right. And then I think to check whether that 0 is a solution, it's pretty easy to see that 0 doesn't fall in either one of those. So 0 is not a solution to that compound inequality. All right, now let's look at number 5. It says write an inequality that represents the statement. It says x is less than 8 and greater than 3. So this is an and statement, so we know what kind of distinct look that has. So kind of put x in the middle here, and x is going to be less than 8, but it's going to be greater than that 3. So we would have, this would be your compound inequality for that. Now this next one, we have x is less than -1 or greater than 2. Now when you have an or statement, you literally have the word or in the middle. So we have two inequalities kind of connected by that or. So we'd have x is less than -1 or x is greater than 2, and there would be your compound inequality. Okay guys, hopefully this will help you with your homework.